welcome back to hello everyone. Welcome back to my YouTube channel. Myself Tanusri am currently pursuing BE in Sri Venkateshwara College of Engineering, Bengaluru, in the Department of Electronics and Communication Engineering with the USN 1V23 EC111. And the subject today I'm going to discuss is network analysis, and the subject code is BEC304. Topic is classification of electrical network. Introduction to electrical networks. Electrical networks are crucial for understanding how electrical components interact. They consist of interconnected elements like resistors, capacitors, and inductors. Classifying these networks helps in analyzing their behaviors and simplifying complex systems. Types of electrical networks. Electrical networks can be categorized based on their components and configurations. They may include linear, non-linear, passive, and active networks. Recognizing these types allows for appropriate analytical methods to be applied. The active components are transistor, diode, LED, photodiode, integrated circuit, operational amplifier, 7 segment display, and battery. The passive components are resistor, LDR, thermoresistor, capacitor, inductor, switch, variable resistor, and transformer. Linear versus nonlinear networks. Linear networks obey the principle of superposition and have a linear response. Nonlinear networks exhibits behavior that cannot be described by linear equations. Understanding the distinction is vital for choosing the correct analysis techniques. Passive versus active networks. Passive networks contain elements that do not supply energy like resistors and capacitors. Active networks include sources of energy such as batteries and operational amplifiers. This differentiation impacts how these networks are analyzed and their performance predictions. Series and parallel configuration. Series networks have components connected end to end sharing the same current. Parallel network has components connected across the common node sharing the same voltage. The configuration affects calculations for total resistance voltage and current distribution. We can see the diagram regarding series parallel resistor circuit and equivalent parallel circuit, and the acoustical and electromagnetic networks. Acoustical networks deal with the sound and may involve piezoelectric elements. Electromagnetic networks focus on the behavior of the electromagnetic fields and components. Each type requires specialized techniques for effective analysis and design. Time invariant versus time varying networks. Time invariant networks have parameters that do not change with time. Time varying networks have components whose value may change over time. This classification influences the methods used for transient and steady state analysis. Graph theory in network classification. Graph theory provides a mathematical framework for analyzing electrical networks. Nodes represent components while edges represent connections between them. This approach facilitates simplification and better understanding of complex networks. We can see the fully connected graph and unconnected graph here or the diagrams. Applications of network classification. Accurate classification of networks enhances design and troubleshooting processes. It aids in the stimulation of electrical circuits, leading to better efficiency and reliability. Different applications such as telecommunications and power systems benefit from these classifications. And conclusion and the future directions. This classification of electric network is essential for effective network analysis. Ongoing advancement in technology may lead to new classifications and new methods. Continued research will enhance our understanding of complex electrical phenomena. Classification or network analysis is basically into four types: based on presence or absence of sources, based on direction of current, based on responsibility of the components, based on characteristics of linearity. Based on presence and absence of a circuit, there are two types: active network and passive network. Based on direction of current, I have unil- unilateral network and bilateral network. Based on responsibility of components, we have lumped networks, and distributed network. Based on characteristics of linearity, we have linear network and learning. This presentation provides a structured overview of the classification of electrical network, emphasizing key concepts and their relevance in network analysis. Thank you for watching the video. For the more contents, please subscribe to the channel. Please like the video, share, and subscribe. Thank you.